Welcome to the session on parametric equations, points of intersection. The objectives for this session are to use parametric equations to solve problems involving coordinate geometry. The x and y coordinates of each point on a curve can be written as functions of a third variable. This variable is usually represented by the letter t and is called a parameter. A curve can be defined by using parametric equations of the form x equals p of t and y equals q of t. Every value of t defines a point on the curve with the coordinates p of t, q of t. Pause the video and have a go at this example. Press play when you're ready to view the solutions. Let's take a look at part A first. The diagram on your screen shows a curve C with the parametric equations x equals at squared plus t and y equals a times t cubed plus 1, where t is a real number and a is a non-zero constant. We are required to find the value of a. So let's solve this. Now at the point 1, 0, we have that x equals 1 and y equals 0. And therefore, if we plug into the equations that we have for x and y, we obtain 1 equals at squared plus t and 0 equals a times t cubed plus 1. Therefore, we have that t cubed plus 1 is equal to 0, since a is a non-zero constant, as shown. And therefore we have that t is equal to minus 1. We can now substitute this value into the equation 1 equals at squared plus t. To give us 1 equals a times minus 1 squared plus minus 1. And of course, rearranging this gives us that a equals 2. And now for part B. We are required to find the coordinates of the points A and B where the curve crosses the y-axis. So let's solve this. At points A and B, the x-coordinate is 0. Therefore, if we plug in a equals 2 into the equation x equals at squared plus t with x equal to 0, we obtain 0 equals t times 2t plus 1. And so we have t equals 0 or t equals minus a half. Now at t equals 0, if we plug this in to the equation for y equals 2 times t cubed plus 1, we obtain y equals 2 times 0 cubed plus 1, which is equal to 2. At t equals minus a half, we can plug this in likewise into the equation for y to give us y equals 2 times minus a half cubed plus 1, which is equal to 7 over 4. So at point A, when x equals 0, y is equal to 2. And at point B, when x is equal to 0, y is equal to 7 over 4. Therefore, a equals 0, 2 and b equals 0, 7 over 4. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So a curve C has the following parametric equations: x equals 4at squared and y equals a times 2t minus 1, where t is a real number and a is a constant. The curve passes through the point 4, 0, and we are required to find the value of a. So let's solve this. At the point 4, 0, we have 4 equals 4at squared and 0 equals a times 2t minus 1. Let's deal with 4 equals 4at squared first. We obtained this from the equation x equals 4at squared, simply by plugging in the value of x equals 4, as shown. We obtained the second equation from the equation y equals a times 2t minus 1, by simply plugging in the value y equals 0, as shown, to give us this expression here. So we have these two equations, and we can now solve for a, since we have two unknowns and two equations. From the first equation, we have that at squared equals 1. We've simply divided by 4 to obtain this. And this implies that t equals 1 over root a. If we substitute this in the second equation, as shown, we obtain 0 equals a times 2 times 1 over root a minus 1. And this implies 2 over root a minus 1 equals 0, giving us 2 minus root a equals 0, which implies that a equals 4. So we have our value of a. This brings us to the end of this session. If you have understood its contents, you should be able to use parametric equations to solve problems involving coordinate geometry. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.